Okay, so we are done with our adding and subtracting integer operations. Now we're going to move into the next piece of it, which is simplifying expressions. So our new unit is going to be on the expressions and equations. So we're going to get into this is really the algebra type stuff that we're going to be doing. We've got a lot of vocabulary today because you need to understand how these different pieces are made up. And then the math vocabulary helps you understand it. So an expression, by definition, is a mathematical phrase that can contain three different pieces. Anybody know what the three pieces would be in a expression?
Terms.
What makes up a term? You're on the right.
Variable.
Variable. Variables.
Coefficient.
You're close.
Symbols.
What kind of symbols?
Additions.
There we go. And the math term for those are operators.
Yeah.
Okay? So yes, it's numbers, variables, and operators. Those are the three pieces that are used to build an expression. Does an expression have an equal sign?
No.
No.
No. So an expression does not have an equal sign, and that's really one of the big keys. Basically, the way I like to think of it, to try to make it a little easier for you, is think of an expression as half of an equation. Okay?
The equation has an equal sign.
And the equation has an equal sign.
Equal.
Now, within the expression, and then you'll actually nail this, there are terms. Each little piece of an expression is what we call a term. So a term is a, what do you think we'd go in there?
Number or variable.
Variable.
Okay.
Coefficient.
So DJ up front, I don't think he said it loud enough for everyone else to hear. He said number, but within an expression, a number now has a special name.
Oh.
Anybody know what the special name for a number would be? No? Coefficient will be part. It is a form of integers.
Constant. Oh.
Constant. Okay? So it has a constant or a variable. So it's going to either have a constant, which is the numeric piece of it, or a variable, which includes the pieces with the coefficients. What signs do you think are going to help separate these? Plus and minus. So they're separated by plus and minus signs. The plus and minus signs are what show us what each piece of that expression is. So some examples of pieces of a term would be stuff like a -50 or 5x, which is also why we're not using x's for multiplication anymore, right? Or 2t squared. So those would all be different types of terms that we would be using in an expression. Any questions on the vocab so far? Okay. Now let's talk about the coefficient. The coefficient is the number in front of a variable. What operation is happening if I have a coefficient?
Multiplication.
Multiplication. Okay? So, for example, let's say I have 4d. The 4 would be my coefficient. Now, as a side note, because it is multiplication, we have the commutative property of multiplication, yes? So does it matter if I write 4d or d4?
Yes, it does.
Well, I'm hearing raise your hand if you think it matters. Good. Hands down. Hands up if you don't think it matters. I heard more than one person say no. That's okay. And you know why do you say it doesn't matter?
Wait, multiplication, right?
Correct.
Yeah, it doesn't matter because addition is like multiplication. However you multiply, it still stays the same. Because 4 times 5 minus 20, 5 times 4 equals 20. So
good. We have the community property of multiplication, right? PJ?
But you can't put unknown amount of groups into fours.
What do you mean?
Like, if you don't know how many groups there are, you can't put 4 in that many groups.
Because what is multiplication? Repeated addition. There is a very specific format to multiplication, yes? That's a saying, I have 4 groups of D, correct? Can I model that?
Yes.
Yes.
Yes, I can say, I have 4 groups, each group has a D in it. That would be the model for 4D. Does that make sense? The second one is saying I have D groups of 4, yes? So I would have D groups of 4. Do I know how many groups I have? So can I model that?
No.
No. So can I actually write this?
No.
No. So does it matter?
Yes.
Yes. So Neil is actually correct. Mathematically it doesn't matter. I would get the same answer. But because I cannot actually model D4, my coefficient will always be written before my variable. Does that make sense?
Yes.
Everybody good on that?
Yes.
Okay. Now, like terms, and here's really kind of the focus for today's lesson, where we're going to be simplifying expressions. They must have the same base or variable, but even within that, and the same exponent. What is the term we use for exponents?
Power.
Power. Okay? So, they must have the same variable, in other words, the same letter associated with them, and they must have the same power. So if I have 6x plus 8x squared, my power is different, so I can't actually combine those, even though they both have the same variable of x. Make sense? Okay, any questions on your vocabulary? Because this vocabulary studying stuff for the rest of the lesson. Good. Okay, that being said, since we've gone through all this vocabulary, what does it look like in practice? So, we have an expression here. So this first part, what is just the number? What's the math term for that? Coefficient.
Because it's being multiplied by a variable.
Because it's being multiplied, and that is a major key. Because it's being part of a multiplicative expression with a variable, that means that is a coefficient. It now has a special name. The D itself is our variable. The negative or minus sign is a operator. The 9 is our,
I mean,
what did we use?
constant.
Constant. This whole piece here, the 4 and the D together,
Term.
that is a term. Technically, the 9 could also be considered a term. So this expression has 2 terms. One is a constant, one has includes a variable. This whole thing all put together is a expression. Good job. So, are there any questions on these terms or what they look like? So, we want you to be speaking proper mathematics. So make sure you're using the mathematical term as you're addressing each of these pieces. Okay? Now, can you guys give me an example of an expression with 3 terms? Kyle? 4c plus 6c squared. Is that a different term? If I have 4c plus 6c, are those different?
Yeah.
That's the same as.
Can I put that as 10c?
Yeah.
So is it really 2 terms?
4c plus 6b.
Plus, I just changed it to 6e squared. Plus or minus
70.
minus 70.
I said B. 70B.
Okay.
It's again confusing.
There, now we made 4 terms. The key here, they all have something different. This has just a c. This has c squared. This is just a constant. This has a d. So that makes each of them different. Does that make sense?
Yes, sir.
Makes them special. Because each one has different pieces to it that I can't put together. The initial one Kyla gave us was 4c and 6c. Technically he's correct, though he gave them as 2 separate terms. But because I can combine them, they're actually the same thing. So it doesn't make them different terms. They're the same terms. You just separate them. Does that make sense?
Yes.
You see the difference between what I just said?
Yes.
Yes, Allison.
So for a term, are we able to just put a variable, or do we also need the coefficient of the variable to make the term?
Great question. I like that question. You said to make a term with a variable, can I just use the variable, or do I need to have a coefficient with it? Believe it or not, that's kind of a trick question.
Because like it.
Because does this have a coefficient with it?
Yes.
Yes, it does.
Oh, well, it's one.
It's 1. I just don't write it. But even though it's just c, technically, every time I write a variable, it has a coefficient. But if the coefficient is 1, we normally don't write it. But technically, every time you write a variable, it has a coefficient.
So would it be technically a term if we just put C?
Yes.
Oh.
It would be because it means that's 1 times c. So it already has a coefficient built in. Okay, here's your chance to show me, are you starting to understand this? So list all the terms on this one, and then you got 3 other ones. So try to finish all 4 of the problems here at the bottom of the page. I'll give you guys about 5 minutes. Okay, so one thing I noticed on this when I was walking around, what's the first thing it says here?
List.
All the terms used.
List. So you should have listed all of your terms, first off, not just circle them, as some did. So what terms did you see in this first problem? 8c,
4C squared.
4c squared,
And 2B.
2b,
And 5.
And then 5's the constant.
5,
But 5's the term.
Yeah.
It would still be a term.
Negative 5? It says minus 5.
Oh.
It says minus 5. Negative 5.
Okay, same.
Guys, remember what I said? I wanted you to start getting to the point where you stop thinking this as addition and subtraction and just look at them as positive and negative terms. This is where we needed to get that leap. Okay? So, if you put 5, I would take that. But I want you guys to start thinking in terms of the sign that is associated with it. Okay? What about for this one? What did you guys get?
5, 7,
Okay, this one, our directions were different, right? Now we're just circling the coefficients. We should have circled the 5, 7, and negative 2.
Why does it have to be the negative?
Because the sign, the
Because
minus.
again, I want you to start thinking of these plus and minus as, instead of addition and subtraction, I want you thinking of it as positive or negative integers. Okay? So, for all of you back home, I apologize. Tanner and Daniil both decided right now it's the best time to go ahead and sharpen pencils. Give an example for the term of each of a like term for each of the following. So if my term is something like a constant of negative 50, what would be a like term? Negative 40. Literally any number, I don't care what it is, positive or negative. No, it's the
I
same.
did negative 1 times 50.
I'm sorry?
I did negative 1 times 50.
Technically, that's the same thing.
Yeah.
So how come we do literally in the numbers?
I'm sorry?
How come we
It
can do it?
says same thing.
Because it's the same thing. It's a like term means it's any constant. Any constant is considered a like term. Okay, what about for part B? 6B. So any variable you want with the b in front of it. Any variable or any coefficient except for 3. Yeah, one for C. Go ahead.
Negative 6, 7, 8.
Oh, that was not necessary.
I did that for D.
Oh no, this is one again. 6, 7.
That's okay. I'll take the points off for homework later. Okay, and then for part D.
I think I'm just gonna put negative 6.
Don't. Asher.
Huh?
3x squared?
I'm sorry?
3x.
3x squared. I thought you said bx squared.
I did X.
Oh wait, it has to be.
Yeah, you need some different number in front of it, yes.
I did X cubed.
No, that would be different.
They don't have
That's not a like term. Again, for a like term, it has to have the same base and the same exponent. So that's why for a b, I could not have put 3b squared. That would not be a like term. Because now I've changed the power. You can't change the power for like terms. Like terms have the same power. Awesome.
If 4 was a variable, what would it be? There's like square, cube, and then what would 4 be? Or is it just
The fourth power. Yeah, we don't have, there's not a special name for fourth. Okay. So, a couple more definitions. Now that we've talked about all the different pieces, let's talk about actually simplifying expressions. We can simplify algebraic expressions by combining like terms. In other words, we're trying to find the pieces that are the same and put them together. That's what simplifying is. Be careful when you're combining terms to check the...
Coefficient.
No.
Variable.
No.
Power.
the operator?
You choose the closest so far.
Number.
Operator. Operator. Operation. Operation.
Coefficient.
There it is. The sign. Again, that's why I said Maya was close, because that operation is really your sign. Is it positive or is it negative? That operation is telling you which way it's going. Okay? So you check that sign that's in front of the term. So here's a chance for you to see if you can do this. So I'll give you a hint. The expression is going to have a whole bunch of pieces to it, because there's a whole bunch of pieces there. Your part B is going to simplify what you wrote out in part A to put it in as few terms as possible. Okay? And then see if you could explain for part C how those relate. I'll give you guys about 4 minutes.
You need to do this all.
Okay, this is actually really fun because, guys, we're recording. This is really fun because we had a lot of different answers. Most people went straight to part B. So it's good to see that you're thinking already in terms of the simplifying, but it said they wanted the expression to represent all of the purchases. So we ordered snacks. They bought the following drinks, which are D's, pizzas, which are P's, ice cream cones, which are C's. So for my initial expression, it should have been exactly what the picture was.
Can't be 2P.
So it should have been P plus P plus P plus P plus C plus P plus C plus P plus P plus C. Now, oh, D, thank you. Guys, quiet down. Again, we're recording. There are several of you that were actually really close, but you had already, a few of you I saw that were close had already associated the ones that came together. So I saw several that did this, which that would have been okay, but really I wanted to start at the very basic, which is listing everything. Because our next part is our simplifying. The simplifying is literally where we put all of the same things together. So if you can start thinking in that way, simplifying means put all the same things together. So what are the same things?
5
P's.
I had 5 P's,
3 D's,
3 D's,
2 C's.
and 2 C's. Now I do want to add another piece, and this is going to get more as we get into the more advanced stuff, but a habit I would like to try to get you guys into early is normally, mathematically, we list our variables alphabetically. So really, I personally would have preferred that this one be written as 2C plus 3D plus 5P.
Why though?
Because it helps to organize things. If it was done alphabetically, it's going to help keep everything in order. So either of those is correct. Okay? I would prefer though that you guys start getting in the habit of doing it alphabetically. And normally do it alphabetically by powers. Okay? Did anybody give part C a shot?
No.
No.
No?
Because we're too late.
You're not lazy. We had a lot of fun trying to figure out the other part.
The purchase is made by the Robinson family.
Okay, but how can this example relate to an algebraic expression?
An algebraic
How does this relate to an algebraic expression?
an algebraic expression.
To explain the how you need to everything.
And then it flies up to like the order.
Not only in order, but also
How you have to pay attention to like, you have to go step by step.
step by step. But how did we organize it? Where did we put it?
Alphabetical
Jack?
order.
May I please do share for
Sure.
Oh,
Alphabetical order.
DJ?
to show that we need to put all similar things together.
Good. So, the biggest way it relates, guys, is even though it was all separated, we needed to put the things that were together the same together. So we had to count all the pizzas and put them all together. We had to count all the drinks and put them together. We had to count all the cones and put them together. Does that make sense?
Yeah.
Yes.
Okay?
We combine
So to explain how this example can relate to an algebraic expression, we take all the things that are the same so the pizza, the drinks, and the cones, and list them as one thing. That's really the biggest thing. All we're doing is everything that's the same. All the pizza gets put together as one piece. All the drinks got together as one piece. All the cones got together as one piece. Does that make sense for you? Does that help you understand what we're doing when we're combining like terms?
Yes.
Okay? Could I put together the pizza and the cones?
No.
No, they're different. Could I put together the cones and the drinks? No, they're different. Could I put together A's and B's?
No.
No, they're different. Can I put together fives and pizzas? No, they're different. Do you understand? Good, I hope so. Because now is your chance to really show me that you're getting this.
Was it
Okay? So this is a two-step process. Color code or use a shape. You can do either one. If you've got highlighters, I'd recommend highlighters. You can also use a colored pencil to kind of circle the things that are the same, or you can just use different shapes. What you're going to do, identify each term and combine the like terms. The first one we did for you. So we used a shape. We did a rectangle around the terms that had a B. We circled the terms that were constants. And then we combined those like terms. So here's again where I want you starting thinking of these as positive and negative numbers. So I have a 14 and a 6, so that combines to make 20 B's. Then I have a plus 8 but a minus 12. So that means my signs are
Opposite.
different. That means we're going to
Subtract.
fight.
Fight.
Subtract. 12 minus 8 give me the 4. The bigger guy was negative. Does that make sense? Questions on what we're doing? Okay, go ahead and knock out the next couple.
That's really cool.
It is cool. Okay, again, we're going to put the same ones together. So these all have a J associated with them. This one is just a constant. Okay? So the ones that we go together, I'm going to add 4 and 2/10, 6 and 7/10, and a minus, well, let's add those first, give me 9, so 10 and 9/10, but then I subtract 5, gives me 5 and 9/10, but the bigger one is positive, so that becomes 5 and 9/10 J. There's only one constant, so I just write it out. Okay? Our next one, we have two types. We've got the C's and we've got the D's. So if I put together my like terms, 20C plus 10C gives me 30C. 8D minus 5D. So they're opposite signs. That means they fight. So 8 minus 5 gives me 3. The bigger guy wins. He's positive. So 30C plus 3D. Any questions on those three?
No.
Okay. Now we're just straight up simplifying the expression. So I need to put together the pieces that I can. So I have a 7A and an 8A. That gives me 15A. My constant is minus 6. I have a negative 3D, a negative 5D, and then a positive 8D. So negative 8D plus 8D. Those are opposites. Anytime we add opposites, we get 0.
What if you put the variable like the
0 times D.
What is 0 times D?
Zero. I just put zero D, but I didn't think it.
Okay, if you put 0D, I'd probably take that, but 0 times anything is 0. So it's really 0.
Yes.
Okay, our next one, we've got a couple of G's, and we have two constants on this one. So first I'm going to put the G's together, 1.5 and 6.5 is going to give me 8. G, negative 10 and a negative 3, they're both negative, so that means they're add them. 8G minus 13. And now we've got 3 different H terms. They're all positive, so I'm going to add all of them. 1/2 and 3/2 is going to give me 4/2 or 2. 2 and 2 gives me 4 H's. I only have one constant, so I just keep it, 4H minus 1. Any questions? Is this starting to click for everybody?
Yeah.
Good. Okay, so now I need you to read the directions, use your prior mathematical knowledge, and see if you can simplify this one. The first key on this, we needed to write and simplify an expression, that should be and, not and, that represents the perimeter of the rectangle below. Rectangle is really important. So here's the interesting part. It says write and simplify, right?
Yeah.
So that means that first off, I should have written it. I know, because it's a rectangle, so it looks like this. Meaning my first step should have been writing out my expression, 12y plus 7 5/10 plus 12y plus 7 5/10. Once you've written the expression, now you needed to simplify it. So I would add together my like terms. That's going to give me 24y plus 15. So you should have had 2 steps to that, right, Tanner?
Yeah.
How many steps did you have?
1.
So did you do it right?
Oh.
Even though you were so excited?
Yeah.
You did get the answer. You just forgot the step because you wanted to jump right in. Okay, one last one to do. You can talk about this one as a table if you want. Okay, let's do a poll first. How many of you didn't think any of them were proper? Didn't circle anything.
That was not me. That was not me.
Okay. How many thought there was one that was correct?
I circled B and wait.
Good. Hands down. How many think there were two that were correct? Ooh, that's not so many.
Me.
Hands down. How many thought three were correct? Nobody? How many thought four were correct? Anybody think all five were correct? So it seemed like the majority felt one was correct. Let's see how that goes. Jackson earned $D in a garage sale last weekend. Their neighbors, the Thompsons, also had a garage sale and earned 35% more than the Jacksons. Guys, please be quiet. Circle any of the expressions that can be used to represent the amount of money the Thompsons earned. So we're going to circle any of them for the Thompsons. So I know the Jacksons were D, correct? The Thompsons, and they earned 35% more than the Jacksons did. So how would I figure out how much they earned?
By adding B, 35% would be.
So, but none of those have 35%.
Well, it's actually just 35B.
So I can change 35% into 0.35D.
Yep.
Is everybody okay with that?
I feel like it'd be-
No.
Wait, isn't it one? Isn't it one?
D is in dollars.
135? No.
It's
Maybe.
1.35B.
I don't trust myself.
Okay. So, well, we have the 0.35D. So does A work?
No.
Why not?
Because it's supposed to be adding what the Jacksons earned. It's not just.
Oh, it's plus what they earn. So is that? Okay. So you're saying B works then? B works?
Yes.
So C.
No.
C.
Yes.
But no, but then you can't add them together because they don't have the same variable.
But you don't know what D is.
No. That would basically be 0.
Hold on, guys. There's a really good conversation happening up here. I'm not sure if the video's picking it up, so I want to reestablish what it said. The consternation comes, are they like terms or not? Can I put them together? So, is it just 0.35 or is it 0.35D?
0.35D because you need to multiply how
Because I have to multiply because it's 35% of those dollars, yes? So yes, B is correct. But because that D is missing, C would be incorrect, A was incorrect. What about D then?
No.
Why not?
No, because
Hold on. Jack?
Because D is adding the total amount that the Thompsons earn,
Okay.
and adding with the amount that the Jacksons earn.
Okay. So they've actually done the D kind of 3 times now, right?
They divided it.
So D doesn't work because that is the Jacksons. This alone is what the Thompsons earn, which kind of answers E. That one also works. So the correct answer was 2. There were 2 correct answers. Because if I add, and remember what we said, if I don't see a number in front of my variable, but I don't have a coefficient, what is it?
1.
1. So if I add that 1 there, now I have 2 D terms. One has a 1, one has a 3500ths, meaning I can combine those. 1 and 3500ths gives me 1 and 3500ths. Make sense?
Yeah.
Any questions on anything we've covered today?
Nope.
Okay, guys, so simplifying should be relatively easy. Good luck to you.